Hi everyone. This is our final product presentation for Project Innovate Future. So this is our team. We have our stakeholders, Dex, Lightsman, and Notel as our tutor, and we have team leads and DevOps and developers. So this project, Innovate Future Foundation, serves as an engaging platform to introduce IFS mission, showcase its work, and provide a centralized hub for managing upcoming events. This project enables organizations and end users plan, manage, and preview the international learning activities in one place.
So through our project, we adopt modern methodologies in project management, system architecture, and technique stacks. At the start, our requirements were unclear, so we took an iterative approach to gradually refine them, avoiding duplicate work. We followed Agile Scrum using Jira, GitHub, and Discord for efficient tracking and collaboration. Can you click Jira board?
Yeah. Okay.
Yeah. In Jira, we planned our work across 6 sprints, breaking tasks into epics, tickets, and subtasks as needed. Okay, can we go back and click GitHub repos? And in GitHub, we manage our code in front-end and back-end repos with each ticket linked to a branch and reviews through pull requests. And these are, commits of the project. For communication, we use Discord for daily stand-up, sprint planning, and retrospectives. Our project was structured and also flexible, balancing efficiency with adaptability. We have already done our best to standardize the project development process. Next slide, please. For our system architecture, the front-end and back-end communicate through RESTful APIs to ensure smooth and secure data flow. Next slide, please. Okay. On the front-end, handles user interactions, while the back-end process requests, manages business logic, and stores data in PostgreSQL. We also created a bucket on cloud to store our static assets, include build files and images. Next slide, please. Since we are building a multi-tenant SaaS platform, role-based access was a major challenge. We have 6 roles, each with different responsibilities. Next, please. We start with the database, where the core resources resolve around organizations, user resources, and tool resources. Data isolation is enforced using org ID, which serves as tenant's identity. Next, please. Next slide. On the front end, UI elements like menu are rendered dynamically based on role permissions defined in the backend permission config file. These permissions are fetched via an API to determine the appropriate UI for each role. However, front-end control alone is not secure, so the backend validates JWT tokens, extracts org ID, and ensures users can only access authorized resources. Next, please. Yeah, next is our tech stacks. Next. Okay, our main tech stack includes React, TypeScript, Vite, 10-stack table, query, and Tailwind 6 is for frontend. And the ASP.NET Core Entity Framework, Mediate are PostgreSQL for backend. Of course, there are some popular packages are used in the project as needed. Next, please. Xiaobao will introduce the authentication part of the project.
Thank you. In our project, we have 2 ways to register. One is organization or the main registration. First thing is to fill in the organization details, then fill in personal details, then submit the form to fetch register organization of the main API. When the user when receive a verification email, user need to confirm. If verify successful, then will direct it to the dashboard page. Otherwise, will show the invalid message. Next page, please. Next is user invitation. Organization of the main invites user via email. System sends an invited email with an verification link. Next page, please. Then when the email sent successful, when the invited email sent successful, then let invited user to check their email and click verification link to get temporary password for login. Next page, please. For authentication, we have 3 APIs: login and get me and logout. We use JSON Web Token to generate an access token. The access token is stored in cookies for security. The reason we use JSON Web Token because it is status authentication. No need to store session data on the survey. For security view, token is signed and verified. Next page, please. For authorization part, inside the access token, we only store profile ID in the claims, easy and safety, because profile ID in our database can allow us to fetch all the informations that we want to retrieve. Thank you.
So for uploading and processing images is a very common requirement in web applications. Our approach involves 2 key steps here: image cropping and uploading to AWS S3. Before uploading, users can crop their image to a desired size. This ensures that only the necessary part of the image is stored, optimizing the storage and user experience. So once the image is ready, it is uploaded to AWS S3, a secure and scalable cloud storage solution. After the upload, we receive an S3 URL, which can be used to display or process the image further. Regarding the forms, we utilize the React hook form to handle the form inputs and validations. This is a demo which includes all the features mentioned above.
Okay, so one of our key optimization is server-side pagination. Instead of loading on large datasets at once, the front-end features only what needed using text-and query, while the backend returns paginated data with metadata for smoother navigation. Next slide, please. As shown, each query can include specific parameters to retrieve the corresponding data. Next slide, please. To further optimize, we use low-dash debounce to limit unnecessary API calls in search fields. Not every change of search content trigger an API call. Next slide, please. Raymond will talk more about responsive design UI.
Okay, thank you, Chen. I'm Raymond, and today I'd like to introduce the responsive design principle used in our landing page as an example and explain how they improve the user experience across the different devices. Next page, please. First of all, we do have a consideration in mobile users and create different layout for different screen sizes. For example, in larger screens, elements are spaced in the better content balance, but also in the smaller screens, the layout will more compact and stagnant for readability. So users on all devices can optimize the experience without unnecessary clutter. Next page, please. To make the layout adaptable, we avoid the fixed pixel values and instead using relative units like the percentage, REM, or EM to have the page remain visually consistent without overflowing or shrinking too much. So you can see that content will automatically fit in different kinds of the content. Next page, please. We also use breaking points to define different layouts for different screen sizes. For example, the layout is single column in mobile, but switches in multi-column in large screens. So the page will dynamically adapt and maximize usability across the screen sizes. And next page, please. Also, we leverage the flexible and the grid to create adaptive structure layout, which we use these techniques, a more structured, organized layout, and adjust it intelligently to different devices. So in conclusion, with the responsive design, our landing page is not only visually appealing, but also functionality and user-friendly across all devices. This ensures a consistent and engaging experience for all the users. Next page, please. And in our project, we also follow modern front-end best practice by using component-based design, a unified UID system, and a smooth animation. Next page, please. We adapted a highly componentized architecture, making it easier to maintain and scale. So we were using the registration process as an example. Instead of writing a separate form for elements and logic for different pages, we encapsulated them into a reusable component, which they have advantages like can you reduce the code duplication, ensure consistency across the application, and make the updates much easier. Next page, please. To maintain a consistent design language, we also use the chassis UI. For example, the bottoms, the inputs, and the models all share with the styling, behavior, and accessibility features. And also we use the smooth page transition with the framer motion. These animations makes interaction feel more natural and engaging, improving the overall usability for the application. The next page, please. Why this matters? By combining the component-based UI, a unified UI system, and the framework motion animations, we achieve these benefits like increase the development efficiency, easier maintenance, and a better user experience. So in summary, our use of the reusable components, chassis and UI and framework motion help us to create visually appealing, efficient, and user-friendly interface. By following this system approach, we streamline the development, delivering a consistent and a smooth experience for the users. And that's the end of my part. Thank you.
This is the demo about the responsive UI and other features we've delivered so far. And we created an account for demo use with some state data injected. Here is our dashboard. Tools, users, different roles with grid table. And this is nested table. We can select different filters, pages to get different data. I want to show not every click triggers an API call because timestamp query caches data for a set duration. This significantly reduced unnecessary API requests by serving cache data when available, improving performance and efficiency. And about tool part and dashboard part, we only build static UI without API linked because of the time constraint. Yeah, this is drop and drag component package. Yeah, I think that's it. Further development will continue later. Yeah, we are sure the developed part can be ready to use. Okay, thank you.
Okay. Hello, guys. Can you hear me?
Yes.
Okay, so good evening, ladies and gentlemen. It's my pleasure to introduce our project on backend infrastructure and DevOps considerations to our STME peers and industry thought leaders. And first of all, as you can see, this is our infrastructure overview. All our domains are managed by the AWS Global High Available DNS service, which is Route 53. And then after we're hitting the edge service called front, we integrate both our front end and back end with into our cloud front as different origins. And the front end part, we have mainly two buckets. One bucket is for the static contents, and the other one is for the images, and also including those images that user uploaded. And for the backend part, we use the API gateway to expose our backend service and integrate with Cloud Map to automatically discover our Fargate service. This will ensure high availability and also auto load balancing. And for the monitoring and logging part, we use CloudWatch to ingest all of the logs and then sync them to the third-party service that we built in the other code. For instance, we built our Elasticsearch and Kibana in Google Cloud GCE. And next page, please. And for the environment design part, we use AWS organizations to provide better environment segregation. And in our case, we have two AWS organizations. One is dev organization, which is solely used to manage dev account. And the other one is main organization, which is used to manage our UAT account, staging account, and production account. Next page, please. As you can see, we have mainly 5 branches. To break them down, we have 3 long life branch, dev, UAT, main. You might be curious that why we put the branching strategy in the environment design, because each of those long life branches are actually logically representing an environment. They are development environments, UAT environments, and production environments, respectively. Codes are promoting from dev to UAT branch and finally into the main branch. For the short life branches, developers mainly develop against the dev branch. They check out the feature branch from dev branch. And also we have a bug fix branch, which can be used to patch hot fix to the UAT branch directly. This clear branching design is very helpful for our pipeline design, which will be covered in our later section. Next page, please. The access control is a crucial part in a project in an organization. Users' permissions must be restricted and managed. Besides, the services and the pipelines that act as human also need to be taken into consideration. For the SSO user management, we use AWS IAM Identity Center to manage our user access across different environments, including dev, UAT, and production. Users are managed in SSO groups so that we can ease the administration overhead. We have developer group, we have DevOps group, we have DevOps lead group, and at the end, we have a platform admin, which have full access, full control across all the environments. Next page, please. For the pipeline role management, our project used GitHub Action to automate our pipeline jobs. And with the help of OIDC, we do not need to expose and store our secrets in third-party service. And as you can see, all the workflow using OIDC to get temporary credentials based on the different assumed policies. Basically, those policies, including 3 different factors: which repository is it come from, which branch is it come from, and which environment is it going to deploy to. And all of them are managed by Terraform. Next page, please. So Terraform is absolutely the most fun part of our project. We adopt enterprise IAC code management. You remember the user access control part that we mentioned before? With the help of Terraform, SSO users can be managed with just a simple pull request. We also tried our best to write our Terraform module as generic as possible for future reusing and for easier maintenance. And we separate our infrastructure code into multiple repositories to provide better segregation and provision speed. And as you can see in the image, there is a Bootstrap. There's a Bootstrap repository called Terraform Bootstrap. That one is used to manage all the Terraform backends, all the TF logs, the TF states, and also the temporary files for all the other Terraform repository. So you don't need to creating them manually and assign those secrets every time when you create a new Terraform repository. And next page, please. I will give this part to Dylan. Dylan, are you there?
I'm Dylan. Today I will be talking about our front-end CI/CD pipeline and preview environment. This setup is important for our workflow, helping us quickly develop new features while maintaining quality. I will explain the architecture, the workflow, and how the preview environment works, as well as the benefits we have seen. Our setup uses a multi-environment approach with development, UAT, and production. We use GitHub Action for the workflow, AWS S3 for the static hosting, and CloudFront for the content delivery. Security is handled using OIDC authentication with role-based access, so we don't need long-lived credentials. This makes the system scalable and secure. Our CI/CD pipeline has 2 main parts: build and test and deployment. The build and test pipeline is triggered by pull requests or changes to main branches. It installs in dependencies, run test, creates a production build, and prepare file for deployment. The deployment pipeline handles the specific settings for each environment, deploys to S3, and invalidates CloudFront caches. This workflow is reusable, so it can be used across different environments with some customization. A major feature is the preview environment for each pull request. It automatically creates a unique environment with its own URL. Each PR gets its own S3 bucket named by the PR number and title. It also triggers the backend to create a matching API preview, ensuring full stack testing. Once the PR is merged or closed, the resources are cleaned up, so we don't have unused environment. All of this happens automatically with no need for manual intervention. This system benefits us in 3 main areas. First, it improves developers' experience by providing quick feedback in an isolated environment. Second, it helps quality assurance by allowing validation before merging. Finally, it boosts operational efficiency by automating resource management and reducing manual errors. To sum up, our front-end CI/CD and preview environment solution has improved our development process by automating development and offering isolated testing environments. We are able to release features faster and with higher quality. Okay, that's all from my part. Thank you. Now let me head over to YC.
Okay, next page, please. So for the CI/CD design part, our pipeline and workflow work closely against our branching strategy. So as you can see, when developer let's from left to right, for the first column, when developer push a started pull request from feature branch to dev branch, it will trigger a dev preview CI workflow, and it will push and tag image. And after that image is push and tag and also tested, it will be deployed to a preview environment. And after that, when it is merged, it will then trigger a new workflow, which is dev CI and dev CD, which is similar to dev preview CI and dev preview CD, but it's work against the dev branch. And after the developer, after we have developed enough features, we want to deploy them to UAT branch, then we just create a pull request from dev to UAT, and so on. What needs to be mentioned is that we have a bug fix. We have a bug fix branch, which is a little bit different. That one is triggered from only the bug fix branch to the UAT branch. And for the production part, the production CI, they actually do not need the permission to push image because we do not allow that, and only tested features on the UAT service, on UAT branch can be promoted to the production branch. And after that, when we push, when the pull request merge on the main branch, it will trigger the deployment pipeline on the production environments. By adopting these image promoting best practice, we can achieve fast reflect and fast deploy because no rebuild is required, and least privilege, and also space saving because we're using a central ECR repo. And next page, please. Now let me hand over to Fan.
We monitor ECS cluster using Amazon CloudWatch. At top of this slide, you can see the CloudWatch dashboard. It provides real-time metrics and alarm status for CPU and memory usage. The alarm will trigger when usage is above 80% for 3 out of 5 data points over a 25-minute window. When either alarm is triggered, an email is sent via Amazon SNS to ensure our team is immediately informed. Now Henry will go over logging on next slide.
Okay, next slide, please. Okay, last but not least, we have our login system. Here we deploy our Elasticsearch cluster on Google Cloud Platform with the Elasticsearch nodes and Kibana node to efficiently store, search, and visual log data. Our cluster consists of 2 Elasticsearch nodes, each serving a crucial role. Node 1, which is master node. This node is responsible for coordinating the cluster, managing metadata, and store a portion of log data. And node 2, which is a replica data node. This node stores replica shards to ensure redundancy and also helps with search queries to distribute the load. Sitting alongside our Elasticsearch cluster, we have one Kibana node. Kibana provides the user-friendly interface that allows us to search and analyze log data efficiently, build interactive dashboard for real-time insights, set up alerts to detect anomalies or security threats. Kibana transforms our raw logs into visual representations, making it easier to understand network activity, detect trends, and troubleshoot issues. One example of how we use this system is with VPC flow logs. These logs capture details about the traffic flowing in and out of our cloud network, including source, destination, ports, and protocols. Instead of manually shifting through these raw logs, we send them to our Elasticsearch cluster, where they are indexed and stored. Then with Kibana, we can create dashboards that visualize network activity, helping us identify suspicious traffic, troubleshoot connectivity issues, and ensure compliancy. Okay, next slide, please. So that's all for our presentation. Thank you for listening. We are Innovate Future Association.